Hey, this is Mr. Persons. Today in our 7th grade accelerated tag math class, we're going to talk about functions. Let's start out with a definition of functions. We're going to look at two definitions here. A simple one, a function relates an input to an output. Very simple definition, just looking at inputs compared to outputs. A more complicated definition, a little more wordy, would be a function relates each element of a set with exactly one element of another set. So we're still looking at inputs and outputs. This definition calls them sets, but we're looking at relating each element of a set with exactly one element of another set. With our functions, we're going to look at three different ways to look at them. The first one we're going to look at is in mapping diagrams. So as we look through these three different methods of looking at it, let's continue to think back on our definition of functions. So with our first one, is this relating an input with an output? So you can see we've got our input here, our output here. The lines are showing us the relation between the input and the output. In other words, this -2 goes to 4. This 2 goes to 4. This 4 goes to 16. So it's relating the input of x to the output of y. Now let's think about our second definition to see if this is truly a function. Does it relate each element of a set with exactly one element of another set? So our first set being here, our second set being here, each element in the first set exactly with one element in another set. So each element in the first set is related to one in the second set, and each element in the first set goes to exactly one in the other set. So -2 goes to 1, 4. 2 goes to only 1, 4. 4 goes to only 1, 16. 5 goes to only 1, 25. 6 goes to only 1, 36. So this is a function. Our second example. Once again, are we relating an input to an output? Yes, we are. This time it just calls an input and output. Now let's look down at our sets. In our first one, we have 0 that goes to -2 and 1. 1 goes to 2, 2 goes to 1, and 3 goes to 4. So let's think of our second definition now. Does this relate each element of a set with exactly one element of another set? So if we look at our first one, 0, is this going to exactly one of the other set? No, it's going to 2. It's going to -2, and it's going to 1. Therefore, this is not a function. First one, yes. Second one, no. The first one does meet the definition. It relates each element of a set with exactly one of another set. The second one does not, particularly that part where it says exactly one to another set. 0 goes to 2 in the second set. You'll notice that in both of them, we've got -2 going to 4 and 2 going to 4. There's 2 here that go to 1 here. Same thing here. We've got 0 and 2 both going to 1 here. That is allowed. In the first example, -2 only goes to 1, 4. 2 only goes to 1, 4. However, on the flip side, here we have 0 going to 2 different ones. That is not allowed. So what we're going to call that is many to 1, 2, -2, many inputs going to 1 output. Yes, that's allowed. On the other hand, 1 input going to many outputs, that is not allowed. Now let's take a look at another form of looking at these in the form of a table. Same thing. As we look at our tables, we're going to keep referring back to that definition. So firstly, does it relate an input with an output? Yes. Inputs, outputs. Now let's check the second definition. Is each element in the first set go to exactly one element in the second set? -1 goes to 5. 0 goes to 3, and so on. Each input goes to only and exactly one output. So yes, this is a function, as it says up above. Our second example. Are we comparing inputs with outputs? Yep, inputs, outputs. Does each input go to exactly one output? 3, 0, 4, 7, and so on. However, you'll notice that my input of 4 goes to both 7 and 14. Since this is a one to many, this is not a function. if we look again in our first set, you'll notice that 1 goes to 4 and 3 goes to 4. This is many inputs to one output of 4. That is allowed. In our second one, we have 1 input to many outputs. 1, 4 goes to 7 and 14. That is 1 to many. That is not allowed. Now let's look at our third and final way to look at functions in the form of graphs. Once again, we're still going to think back to our definitions. So looking at this graph, does it relate an input to an output? So we're relating the input of t to the output of p. Let's look at our second definition. Does it relate each element of a set with exactly one element of another set? So we're looking at element of t to exactly one element of p. So if I look at the t value of 0, does it go to exactly one p-value? Yes, it does. The t value of 0 goes to the exactly one p-value of 3. T value of 1 goes to exactly one p-value of -1. T value of 2 goes to exactly one p-value of 0. T value of 3, exactly one p-value of 1. T value of 4 goes to this t-value looks about 2/3. T value of 5, exactly one p-value. Each element of t goes to exactly one element of p. Therefore, yes, this is a function. Let's look at a second graph. We'll call this x, we'll call this y. Let's see if each x value goes to exactly one y value. Over here, this x value goes to exactly one y value. This x value, exactly one y value. Same here, same here. Now when I start to get over to this right-hand side, this x value goes to here, here, and down to here. That's more than one y value. This x value, same thing, hits here, here, and here. Same over here. I hit an x, this x value hits all of these y values. Even though on the left-hand side it's looking all right, on the right-hand side, as soon as we hit more than one y value, it is not a function. If in one spot an x value hits more than one y value, it is not a function. You'll notice that as we're looking through these graphs, we put a lot of up and down lines on the graph to check it. What we call that is we call that the vertical line test. Vertical line meaning up and down. The vertical line test, if a vertical lines only go through one point on the graph, that means that that x value only hits one y value. If that vertical line goes through more than one point on the graph, like it does on the right-hand side, that does not pass the vertical line test because that means it goes through more than one y value, so it is not allowed. That would be one to many. Lastly, let's look at a couple examples. So the question is it a function or is it not? I'm going to pull up the image and then I'll let you think about it for a second before I give the answer. So first, let's look at this mapping diagram. Remember, we want to think, does it relate each element in the set with exactly one element of another set? So in this one, our sets are x and y. Each element in x, does it go to exactly 1 in y? 3 goes to 10. That's exactly one of the y's. 2 goes to 8. 1 to 6. 0 to 4. -1 to 2. -2 to 2. Each x goes to exactly one y. So yes, this is a function. Don't get confused that -1 and -2 both go to 2 over here. This is an example of many to 1, which is allowed. So yes, this is a function. Each element x goes to exactly one element y, and only one element in y. Secondly, let's look at a table. So once again, the question we're trying to answer is, does each element of x go to exactly one element of y? 2 goes to 7. 3 goes to 5. When we get down to 4, you'll notice it goes to both 2 and 3. So one element in x goes to two different elements in y. This is a one-to-many, so this is not a function. Lastly, let's look at another graph. We're trying to determine if each element x goes to only one element y. This is not a function. Remember, for graphs, we can think of the vertical line test. If I draw a vertical line for x of 1, it goes through more than one y value, meaning that my element x1 goes to more than one element in my set y. This one goes to +1 and -1. That would be an example of one-to-many. Therefore, it is not a function. You'll notice the whole way down, the vertical lines pass through multiple points on the graph. This is not a function. Hope this helps and hope we learned a little bit about functions. If you still need some extra help, check out mathisfun.com and search functions. They have more examples on there and extra explanations. Hope this helped. See you in class.